Hello, everyone. Just going to wait a few more minutes, maybe see if a few more people come. See everyone's doing well. Everyone's feeling good today. That's good. Is everybody ready to do some science? Do a little bit of chemistry, huh? It's going to be fun. So if you haven't watched before, this is the first of our continuing live streams. So we're going to have live streams every Tuesday, Wednesday, Thursday at 2. So make sure you keep tuning in for some really cool science experiments, and yeah, hopefully you learn something. Hi, Callie. We'll give her maybe just one more minute. If anybody's got any questions, shout them out. I'll do the best I can to answer them. I guess someone's going to help me here with the questions. So. As well as the X-Chem team, they can answer some of your questions as well in the chat. All right, so I think we'll get started. So today's video is going to be about acid and base indicators and pH. So of course, I am part of the X-Chem team. My name is Aaron, and I'll be presenting today's video. I'd also like to give a special thanks to NSERC and Actua, our sponsors, for making all this possible. So we're going to start with what is pH. pH is a logarithmic scale from 0 to 14, and it's used to measure the amount of hydrogen ions in solutions, which makes them acidic or basic. pH is equal to the negative log of the concentration of H+, and that's a little mathy. And that's how we measure pH quantitatively, but today we're going to show how we measure pH qualitatively. To do that, we use indicators. So what is an indicator? Indicators are compounds that change color based on pH. And some of these indicators have a pH range, which means they only change color at certain pHs. Today we're going to be using universal indicators. Universal indicators change color at all pHs, and they work at all different pH ranges. So let's begin. So first little demonstration is I'm going to take some water, and I'm just going to pour it into this beaker. And then start stirring it. And then we're going to take some of our universal indicators, see just a little dropper bottle here. And we're just going to add a few drops to the water. And you might be able to see it. It's a very faint green color right now. So also I have here with me some sodium hydroxide and some hydrochloric acid. So you can see our beaker here, a light green color. So we're just going to take some of the sodium hydroxide here, I'll take it in a dropper, and I'm just going to add just a couple drops. And you can see that the color changes almost immediately. And if we add a few more drops, we can get even more color change to purple. So you can see it went from green to blue to purple. So now, if I take some hydrochloric acid, and I do the exact same thing, same beaker, you can see the color change from purple back to blue, and then back to green, and then yellow, and then red. So it's just that easy. So we can see that pH indicators are dynamic, and they're always changing, and they always change. They're not just completely used up when we add acid or base. So I'm just going to. So right here is the universal indicator scale. So this is the scale that we use for our indicator here. So right now, our beaker is red. So we know that what's in the beaker is acidic, about a pH of 2, maybe 3, that reddish pink color. And you can see the orange, the yellow, and the green around 7, which is neutral, and the purples and blues down in the basic. So what if you want to test the pH of something at home, but you don't have a universal indicator? Well, I'm going to show you how you can make your own. So earlier I prepared some boiled red cabbage. Now that may not sound too interesting or appetizing, but I'll show you what we can do with that. So as you can see, I've boiled it and I've taken that water off, and I've put it in a bottle. So I have the bottle here. As you can see, it's kind of a purple color. So we're just going to take some of that. We're going to add it to these test tubes. Just about the same amount in each. These are giant test tubes, by the way. I love them. So also with me, I have some, just some common household items. Right here is lemon juice. So what we're going to do is take some of this lemon juice, and we're going to add it to one of these test tubes. So just pour a little bit in this beaker, and we're going to pour it in. So it was purple, right? You can see all the purple. And as we add the lemon juice, it turns a pinkish red color. So does anyone have any guesses as to what lemon juice is? Is it acidic? Is it basic? Well, another way that we can determine pH quantitatively is to use a pH meter. And you might see the pH meter right here in front of me. I'm just going to turn that on. Set it there so you guys can see it. And I'm going to use the electrode, and I'm going to put it in the pH. So you guys can see the pH here. It's about 2.6. So this is quite acidic. So we know that lemon juice is acidic. and it turns our cabbage indicator pink. So next up, I have a little bit of window cleaner here. Nice blue stuff, take the streaks right off your window. So again, I'm going to pour a little bit into the speaker, and we're going to pour it in the tube. So does anybody have any guess as to what color our window cleaner might turn? Will it turn red like the lemon juice, or is it going to turn a different color? Does anybody have any guesses? And remember, there's tons of different household items that you could try in this. We got a few more coming up. Remember, you can do this at home with just any cabbage. Oh, Taylor thinks it's going to turn yellow. Oh, Madeline thinks it's going to turn purple. Well, let's see. So we add a little bit, and we can see that it turned green. Oh. So we know that it's not the same pH as the lemon juice, but, well, what is the pH? So we'll go back to our pH meter here. We'll put the electrode in. Let's see, 10.7. So remember, the scale goes from 0 to 14, 0 being very acidic, 14 being extremely basic. So 10 is on the high side, so window cleaner is basic, and it turns green in our indicator. So we got a couple more here. Next up, 7-Up, a little bit of soda pop. So now, does anybody have any guesses of what the color the pop's going to turn? Remember not to ever drink anything in the lab. It's an important point. Never put it in your mouth. You never know what could have touched, especially during these times. Don't want to get sick. Red. Well, you know what? That's actually a really good guess. So let's see. So we pour it in, and it is kind of a little hard to see here, but it's actually pink, just a little bit lighter of a color than before. And that's because pop is acidic, but it's not as acidic as lemon juice, which contains citric acid. Pop actually contains phosphoric acid. So just to confirm that, we'll take our pH electrode and put it in. And what do we get? We get about 3.2. So it is a little less acidic than the lemon juice. And we're going to make sure I'm washing. So one last one. This time it's not a liquid, it's a solid. This time I have baking soda. So take just a scoopful of the baking soda right in. As you can see, it's already starting to change color here. Mix it up. Oh, wow, we get a nice blue color. So let's talk more about that color. So here's our indicator scale for our red cabbage. As you can see, it's not the same as our universal indicator. What causes the cabbage to be able to do this is a chemical called anthocyanin, and anthocyanin changes color on different pHs. So you can see red, about 2, which is actually really, really close to our lemon juice. We can see purple, violet, that's about our 4 to 7 range. Blue is our baking soda. So our baking soda is basic, but not as basic as our window cleaner. So also, I was using a pH meter. So you might be wondering how a pH meter works. So a pH meter actually measures the electrical potential of a solution. And has a known solution that it compares it to. And using the difference between the electrical potentials, it can calculate the pH. So I got one more little demonstration for you. This one is a pretty cool one, if you ask me. So I'm just going to take this graduated cylinder here. And with me, I have some more hydrochloric acid, and this already has indicator in it. As you can see, it's red. So I'm just going to pour, let's say, about 75 mils. And I also have some sodium carbonate here. So I'm going to get a little bit closer here. So I'm going to take the sodium carbonate and just gently pour it in. As you can see, as it settles, that we have a bunch of different colors inside of our tube. So on top, it's red, and then yellow, green, and blue. So if you recall that indicator scale, we know that it's likely because all of the pHs are different. So what happened was I didn't mix this. So it just kind of settled that the hydrochloric acid is on top and the sodium carbonate goes down bottom because it's denser. So up here our pH is higher because it's more acidic, and down here our pH is lower because it's more basic. Everybody enjoyed that one, it seems. Awesome. So that concludes our little demos for today. So now I'm just going to stick around if anybody has any questions or anything we wanted to answer, or any more suggestions. I have a few more chemicals here, and I have some more tubes if you guys want to see some more color changes. And before I forget, don't forget to tune in tomorrow when my friends Taylor and Caitlin teach you guys about sound. So what's an example of a situation you would need to know pH? Well, pH is important in a lot of biological systems, including our bodies. Our bodies are typically slightly basic, 7.6. And if our bodies go above or below that, we can get sick or even die. And the ocean is another good example of why pH is so important, because, again, it's important to the fish and all creatures living in there that it be a specific pH. That's a great question, by the way. Great question. Any more questions? While we're waiting for some more questions, I'll throw some more chemicals in there. In our little rainbow assortment here. So with me here, I have isopropyl alcohol, pretty important nowadays for cleaning, used as a disinfectant. So I'm just going to add a little bit. Does anybody have any guesses of what the isopropyl alcohol might do? Just a clear liquid. This is pretty concentrated, about 70%. Kill any germs you come in contact with. So let's mix it. I'll do this closer to the camera just so you can see. Well, didn't really do much, did it? Kind of stayed purple, maybe a little lighter color because it watered it down. So alcohols tend to be not very good acids or bases. They tend to be around neutral. They don't react well with anything, really. That was a good guess, Red. You might think that some alcohols are acidic, but they're actually not very acidic at all. All right, well, that concludes today's live stream. I'd like to thank everybody for tuning in, and make sure you come back tomorrow, same time.